Hello, and welcome to Naptime Videos. My name is Nick, and today we'll be learning about the sliding filament theory and a sarcomere. Alright, well, let's get started. Let's start with the basic anatomy. The sarcolemma is the protective outer coating of the muscle fiber. Muscle fibers also include the presence of nuclei and mitochondria, as pictured here in the blue dots. The mitochondria provide the cells with ATP to be used later on in the contraction of the cell. A muscle fiber also contains many myofibrils that are crucial in contraction. The myofibrils contain thick and thin filaments, or dark and light bands, or myosin and actin, whatever you want to call it. Actin makes up the Z discs, and myosin makes up the H zone. From one Z disc to another is considered to be a sarcomere. The sarcoplasmic reticulum is also very important, but we will get into that later. During muscle contraction, the Z discs, or Z line as some people call it, close the gap between each other. Now getting into the anatomy of myosin and actin. Actin contains two proteins called troponin and tropomyosin, which inhibits actin and myosin from binding together. Since they are proteins, they are able to have their shape conformationally changed by foreign substances if it matches onto the correct receptor of the troponin. Myosin contain myosin heads that attach to actin if the actin is readily available for the myosin to bind to it. To start the process, a neuron connected to the sarcolemma, called a motor neuron, releases the neurotransmitter acetylcholine into the terminal space between the neuron and the muscle cell. The acetylcholine binds to the receptors on the sarcolemma and initiates an action potential that cascades down the sarcolemma. Once it reaches the T-tubule, the action potential travels down and reaches the sarcoplasmic reticulum. The action potential creates a voltage difference, and being that the reticulum is a voltage-gated ion channel, it releases calcium ions to travel down into the T-tubule to bind to the actin. The myosin heads contain ATP, used for energy later on in the action of contraction. Calcium ions released from the sarcoplasmic reticulum bind to troponin, exhibiting a conformational change of the protein, and pulls the tropomyosin away from the actin chain. Since the myosin wants to connect with the actin, the ATP is broken into ADP and phosphate. With that release of energy, the myosin head is able to move and connect to the readily available actin. Once attached, the myosin head pulls the actin laterally, causing contraction. This is the same action that pulls the Z discs together. Once the myosin head has pulled the actin, ATP replaces the ADP and phosphate connected to the myosin head, causing the myosin to release the actin from its grasp and go back to its relaxed state. The calcium ion connected to troponin unbinds, allowing troponin and tropomyosin to reattach to the actin, protecting it from myosin. Here is a review of the steps pertaining to the actin and myosin in the action of the sliding filament theory. Feel free to pause the video to review these steps thoroughly. I'm Nick, and thank you for watching.